Hello, class. These are our informal notes. We are finally learning how to simplify square roots today. So we're looking at a couple properties. One of them is that we can take a square root, we can break it down with multiplication. The other one is we can take a square root and we can break it up with division. So that means if I have a square root of, I don't know, let's say 10, I can make it square root of 5 times square root of 2. That's perfectly legal. And we did do that a little bit in class yesterday. I don't know why we would want to do that, but it is one way that you can rewrite square roots. So we're going to use that to help us out on some problems today, and we're going to simplify the way square roots look. So our first step in simplifying a square root is to make a factor tree. So a factor tree is when we split up a number into all the things that multiply to make it into its smallest little prime factors. So what I mean by that is I might not know lots of things that divide into 150, but it ends at a 0. So I know it's going to be 10 times something. It's going to be 10 times 15. And then I have to think, can I break down 10 or is that a prime number? Well, 10 is really 2 times 5, so I can break that one down. Same thing with 15 over here. 15 is going to be 3 times 5. So it turns out that 150 is all of these little numbers multiplied together. 150 is 2 times 5 times 3 times 5. So if you remember from what we did yesterday, we learned that anytime we have a square, like say I have a 3 squared, and then I take a square root, the square and the root are inverses, and we would just get a 3. So what I'm looking for is I'm looking for two numbers that are the same, right? So I have a 5 here, and I have another 5 over here. So because there's two factors of 5, I can write 5 squared, and then we still have a 2 and a 3. So I'm going to write times 2 times 3. And so when I write 150, I can write that it's the square root of all of these things multiplied together. That's what that property shows me up above. And then what I'm going to do is I'm going to choose to break this apart and we'll say, well, this is the square root of 5 squared times, and then over here, I'm going to write square root of 2 times 3. So the reason that I'm doing that is because now I have the square root and a square. Those are inverse operations. We're just going to get a 5. And then over here, I'm going to actually multiply these two numbers together and make that a square root of 6. So we'd have 5 times the square root of 6, which is just 5 square roots of 6 like this. And there's lots of different ways to read this. I've heard students say 5 roots of 6. I've heard them say 5 square roots of 6. And this is not just students, it's teachers also. I've heard people say 5 radical 6 because technically it is a radical symbol. 5 root 6 where they don't even have the S in there. So there's lots of different ways that we could word this or say this out loud. So I tend to say 5 square roots of 6 because it is a square root, but that's probably the longest way to say this. So I don't really care what you choose as long as we're mathing correctly. So on 24, let's see if we can break down 24. So 24 is 4 times 6, and the 4 is a 2 times 2, and the 6 is a 2 times 3. So I'm looking again for anything that I have two factors of, and I have two factors of 2. So I could write this as the square root of 2 squared times the square root of, what do I have left over? I have left over a 2 and a 3. So all these kinds of ends of my trees, the 2, 2, 2, and 3 are the things that all multiply together to make 24. So really quick, let's finish off this problem, and then I want to look at 24 a little bit more so I can answer one of the common questions students come up with. So my square root and my square here are just going to make a whole number 2. And I want to multiply these two together, and that makes a square root of 6. So you can see I really kind of shortcutted my work this time. So if you prefer this long way, you're welcome to, but I really think many of you will be able to kind of jump to this kind of shortened work right away. So students always ask me, well, what if I break down 24 a different way? What if I say that 24 is 2 times 12? Am I going to get the same answer? And the answer is yes, because I can still break down 12 and make that 3 times 4, and I can still break down 4 and make it 2 times 2. And you can see that the ends of my little trees, so I wouldn't count the 12, right? It has the branches still coming off of it, but all of my ends are still the way. It's still the same. So it doesn't matter which way I break a number down, these little ends of my branches are all going to be the same. All right, let's look at the next one. The next one, I have a square root of a fraction. So I know that that means the square root of 15 divided by the square root of 64. So let's look at each of these separately. So when I look at the square root of 15, I would need to see what kind of factors, how could I break down 15? And 15 is just a 3 times 5. So since there's no repeats there, I don't have 2 5s or 2 3s or 2 2s or anything, it's already simplified at the square root of 15. So I'm done. Now you might recognize 64 from our work yesterday. So if I don't recognize it from our list of perfect squares yesterday and I go to break it down, I might come up with 8 times 8. And I could keep going, but honestly, like right here at this point, here's two numbers that multiply to make 64 and they're the same. So I'm really done. I can make this the square root of 8 squared, and that's just going to be an 8. So now I have square root of 15 divided by 8, or the square root of 15 eighths. That's a very weird fraction. So let's try the same thing on the next one. I need to break this apart into numerator and denominator. And we'll look at the numerator first. Let's see what we can do with 18. So 18, I could say 9 times 2 or 6 times 3. And hopefully you know by now that it doesn't matter which order you break this apart in. We are going to get the same numbers at the very end. 9 is 3 times 3. So we end up with 3 times 3 times 2. So I'm always looking for 2 of the same factor. So I have 2 factors of 3. So that means my 18 I can rewrite as the square root of 3 squared times the square root of 2. So these guys are the ones I want together because I know I can square root a square. This is the one that's kind of left alone inside my square root. All right, for 49, hopefully I recognize that off my list of perfect squares yesterday as well. 49 is 7 times 7. Those are both the same. So I can write it as square root of 7 squared. So now I'm going to take my square roots. So I can take the square root of a 3 squared. My root and my square are just going to make a whole number 3. This is going to stay a square root of 2. And then in my denominator, I have a square root of a square. So again, those are inverse operations. They're going to undo each other, and we are just left with 7. So our final answer is 3 square roots of 2 divided by 7. I know it doesn't look simpler to you. That's the other interesting part. But we really like these whole number denominators in math. We'll do more with that later on, especially next year in geometry. So on this problem, I am evaluating a square root, and I'm given a bunch of numbers. So this says square root of, okay, we'll substitute everything in, b squared. Well, b is negative 8. Make sure you put your negative 8 in parentheses because I need to square all of it, the negative and the 8, minus 4 times a is 2, and c is 4. So I need to extend my square root a little bit. So let's see, square root of negative 8 squared means negative 8 times negative 8. That's going to make it a positive 64 minus, and then my next step is going to be doing all of that multiplying over here, right? 4 times 2 times 4. So let's see. So 4 times 2 is 8 times 4 is 32. And 64 minus 32 would just be the square root of 32. So before in math, we would have left this. We would have been perfectly happy with this answer. But now that we know this stuff about square roots, I can do a little bit more work and I can break it down. So 32 is 4 times 8. And 4 itself would be 2 times 2. And 8 is 4 times 2. And this 4 is another 2 times 2. So we end up with just a bunch of 2's. 2 times 2 times 2 times 2 times 2. So let's remember, anytime we have 2 of the same factor, it's something squared. So this is going to give us a 2 squared. This is going to give us another 2 squared. And we're going to have a 2 left over. So this one's going to be a little bit different this time. So this is going to be one pair, and this is going to be our other pair. So let's write it out. So 32, I can now write as the square root of 2 squared times the square root of 2 squared times the square root of 2. And that's because I have 1, 2, 3, 4, 5 factors of 2 there. So every time I have a square root or root, it's going to make a whole number 2. This one's going to make a whole number 2 as well. And we're left with a square root of 2 inside. And then 2 times 2 is 4. So 4 square roots of 2. I'm sure you can see some ways by now that you could shortcut your work. Please talk to your teacher about that. I don't have a problem with it, but I really think today, especially in our notes, it's important that we show this step so that we really understand where is the square root going. When I have students that just jump from the square root of 4 to a 2, they always ask me, like, where is the root going? How do I know what to do? When do I know to get rid of it? And so I really feel like writing this as a 2 squared with the square root and recognizing that the root and the square cancel each other is kind of the key to not making some of those mistakes. So let's go ahead and finish up our notes. We've got a couple problems left. These are ones that you would be trying on your own in class. So 23 is a prime number. With fractions, I'm going to break it up over the top and bottom. And then hopefully we recognize 9 right away off our list of squares. 9 is 3 times 3. So this is going to be square root of 23 over square root of 3 squared, which is just square root of 23 over 3. All right, next is 80. 80 is kind of a tricky one. So 8, I can see an 8 times 10 right away. And again, there's no wrong way to start this. And 8 is 4 times 2. This 4 is another 2 times 2. 10 is 2 times 5. We end up with 2 times 2 times 2 times 2 times 5. So it looks like we've got the 2 pairs of 2 again, just kind of like we did on the 32 on the other side. So these 2 are going to be a nice square root we can take. Same thing for these 2. The 5 will be left over inside the radical. So we'll have negative of 2 squared times square root of 2 squared again. I don't think I said square root of this one, but square root of 2 squared times square root of 2 squared times square root of 5. So this is going to be negative. This is a 2. Here's another 2 because my square and my root are quote unquote canceling. And then I'm left with radical 5 over here. So negative 4 square roots of 5. All right, next problem. And you could definitely be trying these on your own. It's probably good if you just pause it and try 3 and 4 on your own if you haven't already tried that. And then kind of watch my narration here. So this one I'm going to break up as square root of 27 over square root of 100. So 100 right away we should recognize as 10 squared. So my denominator is just going to be 10. The numerator I need to do some work. So 27 is 3 times 9, and 9 is 3 times 3. So we've got that same thing going on this time where we have 2 factors of 3, and then we have a 3 left over. So we have a 3, a 3, and a 3. So square root of 3 squared times an extra square root of 3, which is going to make 3 square roots of 3. And of course 10 in the denominator. So 3 square roots of 3 divided by 10. And our very last problem, another one where we're substituting into a square root. So square root of b squared is going to be the quantity negative 6 squared minus 4 times a is 2 and c is negative 5. All right, so order of operations says do my exponent first. So negative 6 times negative 6 is a positive 36. And then we're going to start multiplying the 4 times 2 times negative 5. So let's see. So if I'm going to cover up this minus sign right now, right, because I'm not using that, I'm just multiplying all of these. 4 times 2 is 8 times negative 5. Well, 8 times negative 5 would be a negative 40. And now I have a minus negative here. So what I'm really doing is I am really adding a positive. We do keep, change, flip, or think about these two together being a plus sign, but I end up with a 76. So if I have the square root of 76, now I need to break that up. So this one's a little bit tricky for me. I'm not sure what divides into 76, but I do know it's even. So if I divide it by 2, let's see what we get. What is 76 divided by 2? Totally cheating with the calculator right now. We get 38. Well, that's still even. So let's divide by 2 again. That's going to be a 2 times 19. And I know that 19 now is a prime number. So sometimes you have to look for tricks, like is it even? Can we divide it by 5? Does it end at a 5 or 0? So I've got the 2 that are the same. So I'm going to make this the square root of 2 squared times the square root of 19. And the square root of 2 squared is just going to be a whole number 2. My square and my root are inverses. So I get 2 square roots of 19. So as always, make sure that you're using your class time wisely and you're asking for help if you need it.